Welcome to Chemistry Wide. Today we will see reaction intermediate. See the point. The most of the organic reaction occurs through the involvement of certain chemical species. Example, this is the tertiary carbon. This is the tertiary carbon. This is tertiary halide plus OH minus gives NaOH. It gives C3R group and OH. This is the substitution reaction. See, these 3 methyl group or this 3R group, there is very crowded. There is found 3 group, so electron density is crowded plus OH minus ion. So already here electron density crowd, here also extra 1 electron, so it gives OH minus going to join with the carbon. This halogen taken two electrons or 1 bond. It is going to outside as a leaving group X minus or X negative charge. The leaving group means which is going to outside when occurs reaction. So reaction begins. So this carbon has negative charge, so OH is going to attack this side, back side. So we get product R3COH. This is called carbonium ion. Once forms carbonium ion, OH minus going to attack and give the product. Here carbonium ion is a intermediate. See, what carbonium ion is only one intermediate. OH is the nucleophile. Nucleophile means electron loving group. Next, here at the first step, the substrate involving OH minus is a substrate. Here OH minus a substrate. This is going to reaction. It is slow step and called the rate determining step. Next, this is called substitution nucleophilic unimolecular reaction because here only one substrate involving or SN1 mechanism. This is very short time mechanism. See the value 10 power minus 6 second only. Next, how to form carbocation? See the carbocation. The chemical species bearing the positive charge of carbon carrying 6 electrons in its valence. We know that carbon valence electron is 4, but here added 2 extra electron. In its valence shell are called carbocation or carbon ions. Example, this carbon chloride between the bond breaking. So this carbon attained positive, this chloride is going to negative. The carbon atomic number 1s2 2s2 p2, this is the valence electron. Here 4 electron at a second energy level. Here Cl is the nucleophile, chlorine as the one extra electron, it is act as a nucleophile. By electrolytic cleavage of the covalent bond which is the leaving group takes away with it the shared pair of electron of the covalent bond. For example, see this example. There is the 3-methyl group, the carbon, chlorine. So chlorine pulling the one electron from the carbon, so it is gives CH3 thrice, carbon attained positive charge plus Cl minus. So this gives tertiary, this is give secondary. See this is the tertiary methyl group, tertiary butyl chloride, the whole name is tertiary butyl chloride. So more stable because here 3-methyl group and steric hindrance. Steric hindrance means more crowded or electron density, higher electron density. This is the secondary carbocation, this is the tertiary carbocation. Here 2-methyl group only, so less stable than tertiary carbocation. See the stability order. So stability order going to, we know already stability order. Tertiary is tertiary means it is denoted, this is the more stable. Again this is the secondary is less stable, primary is very less stable. See CH3 CCl, here primary, this chlorine is primary, this primary, this group is, this is the primary, less stable than tertiary and secondary. Next, carbanion, the chemical species bearing a negative charge of carbonium and processing 8 electrons it is in valence shell are called carbanion. Note, if carbon has a negative charge, that is carbanion. See the example below. See, this is the CH2, this carbon pulling the one electron from this hydrogen, this hydrogen giving the electron, or carbon is pulling the electron from this hydrogen. Anyway, but both are possible. So this carbon again attained partially positive charge. In this time add a one base. We know that base is OH minus. See here XY electron withdrawing electron. This is the withdrawing electron. Example NO2 etc. Here hydrogen electron moving to carbon atom. So it is attained partially. So this carbon attained partially positive charge. In this time add a one base. So for example, how came this base? If take sodium hydroxide, this is splitting Na plus and OH minus. This OH minus is going to attack this hydrogen partially positive. So OH minus and here H plus both are joining together and give water. Here the X group is the Y group. This carbon pulling the one electron from this both hydrogen. See below. So this carbon attained negative charge. This is called carbon ion. See, what is the condition for the form carbon ion? See the condition. Answer: one or two electron withdrawing group attacked with carbon. For example, see the example. This is the hydroxide ion. This hydroxide ion pulling the electron from hydrogen. Again this carbon pulling the electron from this bond. This is the acetaldehyde ion. This is the hydroxide ion. So it gives H2O plus carbon ion and CHO. This functional group is called acetaldehyde carbon ion. Next, second example. This is the amide ion. Amide ion, nitrogen pulling the one electron from the hydrogen. This carbon pulling the one electron from this bond. So this triple bond is, we know that sp3 hybridization. Sorry, this pi bond only sp3 hybridization. This is common name acetylene. Or ethine. So it gives ammonium plus the carbon ion CH. This is the acetylene anion. So this carbon attained one negative charge. It means this carbon have one extra electron. So this is called acetylene ion. Note, CH3 is sp3 CH is the sp3, sorry, CH4 is the sp3, 25% S character. This is the single bond. CH2 is the double bond. This is the double bond. This is sp2 hybridization. Here S character is 33%. CH triple bond CH, sp hybridization. This is the 50% of S character. Next, move on. Free radical. A free radical may be defined as atom or group of atoms having an odd or unpaired electron. For example, if we take chlorine molecule when treating with sunlight or heat, here both chlorine atoms have electronegative. So this chlorine break like this. This is the chlorine free radical. Here chlorine, this chlorine already joining at single bond. This chlorine going into free radical, this chlorine going to free radical. This same type of element bond breaking it is called homolytic cleavage, because both are same atom. See here one chlorine free radical, here one chlorine free radical. Another example, see, this bond breaking, this arrow, fish hook arrow denoted one electron. See here two hydrogen, see the hydrogen, here two hydrogen, so it gives or CH2 radical, Cl radical, or 1 degree primary free radical. Here only one hydrogen atom, so this is secondary 2 degree free radical. Next, here there is no any hydrogen atom, so R3 C radical. This is called 3 degree tertiary free radical. Next, methane and chlorine when treating with sunlight or heat, it is going to methyl chloride. Here one hydrogen going to add chlorine. This one hydrogen break and going to add one chlorine. Again this one hydrogen going to add chlorine, so we get CHCl3. Again one hydrogen going to add chlorine, so we get CCl4. This is the product. This is the one of the best example for free radical. This is called carbon tetrachloride. This reaction occurs due to chlorine free radical. See RCH2, this is the primary radical, CH double R group and CH, this is the 2 degree. Here 3 R group and carbon, this is the tertiary radical. This is the general trend for free radical. Stability order, here more stable 3 degree, tertiary less stable 2 degree, very less stable 1 degree. This is the stability order. Again see, this is the tertiary carbon ion, this is the secondary carbon ion, this is the primary carbon ion. The stability order here 1 degree is more stable, sorry 1 degree is more stable than 2 degree, 2 degree is more stable than 3 degree. This is the reverse order because it is carbon ion. Note this point, at the carbon ion, if we see stability order is going to back because this is the carbon ion, not carbocation. For understanding, say CH2 is carbon ion more stable because less crowd. There is only one R group. This carbon ion has 2 R group, less stable because more crowd. This carbon ion 3 R group, very less stable because very more crowd. There is more crowd of 3 R group. So here stability order say, note, this is the very important note, at carbocation 3 degree is more stable, then 2 degree, next 1 degree. At free radical 3 degrees more stable than 2 degree and 1 degree. But at carbon ion it is the reverse, 1 degree is the more stable, then 2 degree and 3 degree. This is the reverse order at carbon ion only. Please subscribe the channel, more videos on the way. Have a nice day.